Okay? What's the probability of not selecting a numbers card? This is not a numbers card. Numbers are only these. So how many numbers do we have in here, here, and here, and here? So it's 9 times 4, which is 36. What's 52 minus 36? So what would be the probability then? 16 over. Everybody find your calculators because you need them for notes today. I posted this diagram. You do get to use this on tests and quizzes. So this is posted on Schoology if you ever lose it. Okay, you can print it. And in your notes packet, please go to page 15, which is section 11.6. And events involving not and or. Those are the two that we're going to focus on today. So the question that I was asking you not, we're actually going to jump into the example and I'll show you two ways to do it and then I'll explain this formula. If you are dealt one card from a standard 52 card deck, find the probability that you are not dealt a queen. So just the way that I explained this a minute ago, how many cards are not a queen? First of all, how many are queens? 4. So what you have to do is take 52 minus 4, which is 48. And so now what's the probability of not getting a queen? 48 out of 52, which is, please reduce this on your calculators. You need to be good at reducing these. 12 over 13. I would like to explain this in a different way because this is when you just subtract the cards. The probability of an event not occurring. P of not E, so basically it means probability of something not happening, is found by doing 1 minus the probability of it happening. And here's the idea. The 1, whenever you talk about probability, it's the 100% that something will happen. And what you're doing is you're subtracting the probability that it will happen. So in this case, 100% in terms of numbers is 1 minus, what is the probability of actually getting a queen? When you have a deck of cards, what's the probability of getting a queen? 4 out of 52, okay? So what's 4 divided by 52? One over 13, okay? So let's do 1 minus 1 over 13. Can you do this on the calculator? 1 minus 1 over 13? And another way to do it, it's like, what's 1? 1 with the common denominator is 13 over 13. What's 13 over 13 minus 1 over 13? What do we get? 12 over 13. So I get the same answer. That's the whole point. But I explained it in two different ways. One way is when you're actually finding how many cards are not queens. And then you're just doing it 48 out of 52. So maybe that is kind of easy for you. However, the formula for the word not in probability always involves 1 minus. So the probability of an event not occurring is equal to 1 minus the probability that it will. And this is what you're going to see like in any video that you're going to watch, any book, or any worksheet that you're going to get, okay? And basically you do 1 minus, what's the probability of it happening? So let's try this next problem with this 1 minus idea. And as soon as you see the word not, that tells you got to do 1 minus. If you are dealt one card from a standard 52 card deck, find the probability that you are not dealt a diamond. So before we do it with the 1 minus, what's the probability of getting a diamond? How many diamonds do we have? 13 out of, what's 13 over 52 in fraction form? 1 over 4. What's 1 minus 1 over 4? 3 over 4. So with the 1 minus, you actually find the probability of getting a diamond, subtract it. Now let's talk about it in this way, because some people like this way better. You have 52 cards. How many are not a diamond? How did you get that? Right, we subtract minus how many diamonds are there? Okay, so there's 13 diamonds, so 52 minus 13 is 39. So we would have 39 over 52. Can you reduce that? What's 39 over 52? Jacob, what'd you get? 3 over 4. We get the same answer. Okay? 3 over 4, 3 over 4. So if you like doing it this way, where you find how many are actually meeting this criteria, how many are not diamonds, and then doing it out of 52, or you can just use the formula that says 1 minus, what's the probability of getting a diamond? Okay? Some problems are easier with the 1 minus. Certain problems are easier when you just do it this way. Why don't you guys read example 2 to yourself? The graph shows the distribution by branch and gender of the 1.37 million or 137,000 active duty personnel in the U.S. military. Numbers are given in thousands and rounded to the nearest thousand. If one person is randomly selected and the distribution is the same, find the probability that it is not in the Army. So we're going to do it in 137,000. This is 1,370,000 because that's going to be a little bit easier to do the numbers. So how many are not in the Army? So we have, first of all, we got to figure out how many are in the Army. So this one breaks it up as men and women, and it doesn't really specify in this question which one we're talking about by gender. So how many total do we have? 470. So one way to do it is, this is my total in thousands. This is how many thousands are in the Army. So I'm going to subtract 1,370 minus 470 gives me 900, and it's in thousands, so it's really 900,000. That's how many are not in the Army. So what's the probability of selecting that? You're going to do 900,000 over, what's the total? 1,370,000. Which if you do reduce it, it's 90 over 137. Okay, I'll do the math for you. Do you want me to explain it with the 1 minus formula? I'll explain it just for consistency's sake. So it's like 1 minus, what is the probability that someone is in the Army? So what you would do, how many people are in the Army? 470 over, what's my total for this table? It's the 1,370,000, but I'm doing it in thousands, so it's just this. And then if you subtract, you get the same answer. 1 minus the people in the Army. What's the probability of getting that? And you do get 900,000 over, and you can check this on your calculator, which is 90 over 137. So you don't have to do it both ways when you're doing these problems. Which one seems easier? When you find the difference first, or when you do the 1 minus? 1 minus. Some people like the 1 minus because then they just have to focus like, oh, what's my probability of getting someone in the Army? And then subtract minus. Okay? And depending on the problem, you might have an easier way doing it with the 1 minus or just subtracting it like this. Does that make sense? Somewhat? Let's talk about the word or. And you guys have been doing the or problems already on the Kahoot and on the warm-up. So I'll have you try example 3 on the next page before I explain this. So if one card is randomly selected from a deck of cards, what is the probability of selecting a king or queen? So how many kings do we have? 4. How many queens do we have? And when we're finding the probability of getting a king or a queen, what would you guys do with these two numbers? Add them. That's the whole idea with the word or. When you see the word or, if A and B are mutually exclusive, then P of A or B, this means probability of A or B happening, is when you add them. 4 plus 4, which is 8. 8 out of 52. When you reduce it, is 2 over 13. So the whole idea with the word or means that you have to add the probabilities, because it's like adding 4 over 52, 4 over 52 together, and you get 8 over 52. So some of the things that you will have to have memorized from this section is the fact that if the word not is present in the problem, that means it's 1 minus. If the word or is stated in the problem, you're going to be adding the probabilities. On Monday, we're going to talk about the word and that's going to mean multiply. Okay? Try example 3b. It says if you roll a singe, basically a cube, a 6-sided die. I've never heard this word before. What is the probability of getting either a 4 or a 5? As soon as you see or, you know you're going to be adding, okay, with probability. How many 4s do we have on a dice? How many 5s do we have on a dice? There's only 1. So you're going to be adding them, which is 2, out of how many numbers? 6. So 2 out of 6 is 1 over 3. I'm going to stop right here. Well, should we just finish this? Let's just finish this so that we have everything done. The or probabilities with events that are not mutually exclusive. So what is the difference between not mutually exclusive and mutually exclusive? For cards, can you have a card that's both a king and a queen? No, it's either this or this, so they're separate. However, certain problems, you might have things that overlap. Here's an idea. I asked this of my period 2 class. Here's an ice cream pole, vanilla and strawberry. How many people like vanilla? So I counted 1, 2, 3, 4, 5, 6, 7 people. How many people like strawberry? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many people like both? 3. So if I was to count the total, how many like vanilla? 1, 2, 3, 4, 5, 6, 7. So that would be 7 for total. How many like strawberry? 1, 2, 3, 4, 5, 6, 7, 8, 9. Which one did I count twice? The one in the overlap, in the middle. So if I add 7 plus 9, that's 16. However, how many people answered my question? Only 13. So what do I have to subtract from my total? The overlap that got counted twice. So that happens with the not mutually exclusive, meaning these 3 people could be in this category and they could be in this category. So when you're doing this formula, what's different is you're adding probability of A happening, probability of B happening. The same idea as before. We're adding because of the word or, but what do you have to subtract? you have to subtract the probability of the A and B happening because you end up counting it twice, just like in my example. We counted vanilla, we counted strawberry, we got to take away one set of these 3 people because they already got counted. Okay? So let's try example 4B. I'm going to jump to this one. In a group of 50 students, 23 take math, 11 take psychology, 7 take both. If one student is selected at random, find the probability that the student takes math or psychology. The word or means plus. Because I have this 7 take both, I'm going to have to subtract that number. So my probability, let's just follow this formula. What's the probability someone is taking math? It's 23 over out of the total, which is 50. Plus, how many take psychology? 11 out of 50. But then, what do we have to subtract? Minus the 7 out of 50 that take both. So please type that into your calculator, see what you get. Let's actually just maybe, do the top. What's 23 plus 11 minus 7? Just this top number. What's 23 plus 11 minus 7? 27 out of 50. Which does this reduce? I don't think it does. Okay. Another way to think about this, if anybody, if this formula is not pleasing to you, if you don't like doing it this way, you can think of it this way. 23 people take math, plus 11 take psychology. So that's 34 people. But how many people are in the middle? How many people take both? So if I subtract 7, I get 27 take math or psychology, okay, out of 50. So that's another way to do it. All right, I'm going to have you guys try example 4 on your own. Why don't you read it? Take a moment to answer it. This one is about baboons. It's kind of funny. And then I'll just show you the answer when you're done.